This video will give an overview of the Inspect Surface app, which, as the name suggests, allows a surface to be inspected. There are a wide range of potential use cases for this really useful app. Check the flatness of floors, check the verticality of walls, check the correct positioning of cylindrical silos, comparing two scans, for example, a dam wall before and after water being contained in the dam, and many, many more. The key feature of this app is the 3D visualization of measurements compared to the reference surface. This app can save an enormous amount of time and money by allowing the surveyor to make decisions in the field. The surveyor can easily identify any problems with the surface and immediately point to the problem areas using the red laser of the total station, allowing any remedial work to be immediately carried out. Previously, such decisions could only have been made after returning to the office and post-processing the measured data. We will learn how to use this app by going through 4 different tasks using 4 different data sets. Let's jump straight into using the app with a very simple but common use case. This is to check the flatness of a poured concrete floor. I will go quite quickly through the first use case to show how simple the app is to use. In the other use cases, I will go more slowly and explain the app in more detail. We have already scanned the concrete floor with an MS-60. This job also contains a design point. The height of this point is the level to which the floor should have been poured. We move this job to the centre of the carousel and start the Inspect Surfaces app. Firstly, we need to create the reference surface. The reference surface can be thought of as the design or what the surface should be. In this case, we want to use a predefined plane, a horizontal plane defined by one point. We select the correct point which defines the design height of the concrete floor. The object to be compared to this reference surface is an existing scan, which on our site was pour number 7. In the Define Colour Scale panel, we define how we want the variations in distance of the scan from the reference surface to be coloured. We know the floor is quite flat, so we enter relatively small values. We press OK to see an overview of what is about to be compared and then press OK again. The surface is analysed and the 3D viewer results drawn. Here is where we can really inspect the surface. On the right hand side we see the comparison of the scan against the design. The colouring indicates the differences between reality and the design. Remember, blue indicates where the concrete surface is lower than it should be, and red is where it is higher than it should be. Note that we are currently in the compare mode. This means that if we tap on a scan point, we can see on the left hand side the perpendicular distance from the scan point to the reference surface. We can also see the actual coordinate and the coordinates of the scan point if it were projected to the reference surface. If we press Measure, we switch to the Measure mode. Here we can tap and hold to make the context menu appear, and then we can make the total station turn to the selected location. If the red laser pointer of the total station is on, we can easily indicate to the foreman where remedial work is needed. The capture key allows a screenshot to be made. It can be sketched on and stored as usual. There are also tools available. One tool allows a statistical report to be viewed, giving an overview of the results. And the second tool allows the results to be exported using a style sheet. This style sheet creates this report and is delivered with all instruments. It creates a report containing summary information, statistical information and graphical information. Different style sheets can of course present the data in different ways. Let's go through the app in a little more detail with a second use case. This time we will check the verticality of a wall. For this task we will not use multi-station scan data. We will use a grid of points which were measured using a TS16 total station. The Inspect Surface app is not only for multi-station scan data, It can be used with any total station data, but more data can be collected more quickly with a multi-station. Again, we have already measured the wall and have the design data of the wall in the job, so we can start the Inspect Surfaces app. As before, the first step is to create the reference surface. The options which are available are to measure a new scan, choose existing scans, choose existing points, define a plane or a solid object, or create the surface from a file. File types which are supported are PTS scan files, DXF files, or ASCII files. For this task, we need to use a predefined plane. The options which are available are a horizontal plane defined by 1 point, a vertical plane defined by 2 points, a plane defined by 3 points, or a cylinder defined by 2 points and the radius of the cylinder. We need to create a vertical plane from 2 points. We select the 2 points from the 3D viewer, and an indication of the plane is shown by the orange lines. We now choose the object which is to be compared to the vertical wall. The options which are available are to measure a new scan, choose an existing scan, select points, or measure new points. In this case, we will select the points which have already been measured from the job. We do this in the 3D viewer, and the easiest way is to use the multi-selection window. We now need to define the colour scale. It is recommended to carefully choose the distances and colours to get as much information as possible from the 3D viewer. Up to 6 distance steps can be defined. A really nice feature is the ability to save and load different colour scales. This means it is possible to build up a library of colour scales which can be loaded depending on the surface being inspected. We choose our predefined colour scale suitable for relatively flat surfaces. Press OK to get an overview of what will be compared. The surface names are later used in any reports which may be generated. Press OK and then we can see the results. Here you can see that although the wall was measured using a TS16 and not a multi-station, the result is still impressive. The measured points are coloured according to the distance from the reference surface. Let's look at a third use case and look at some more features within the app. This time, let's check the correctness of the positioning of a cylindrical silo. For this task, we will again use multi-station scan data. The surveyor has been out on site and has scanned a lot of other buildings, including a cylindrical silo. By comparing the actual scan position of the silo to the design, we want to know how accurately the silo is positioned. We choose the job and start the app. In this case, the reference object is a predefined solid and it is a cylinder. In the job are the points which define the top and bottom of the cylindrical silo, and we know the radius of the silo is 1.25 meters. Existing scans will be compared to the silo design, and we need to choose the scans which include the silo. We are not actually sure which scans exactly include the silo, but it doesn't matter. We simply select all. We will load and use an already predefined colour template. Press OK, check the overview, and then press OK to compute and view the results. Remember, we chose to include all scans which were made in the area, and therefore the surrounding buildings are also compared to the reference surface. When the results are drawn and we navigate around the data, we can see a lot more of the scan data is being included than what is really needed. If we go to the settings page, we can define the range from the reference surface which should be considered. Any scan points outside of this range will then be ignored. We set a suitable range, and now we can see that all non-relevant scan data is ignored and more clearly see how closely the as-built silo fits to the original design. For this task, we can also look at another feature in the measure mode of the app. We can turn the instrument to the silo and make measurements to the silo with the instrument. We can then view the position of the measured object relative to the reference surface. A really useful feature. Let's look at one final use case to compare a dam wall which was scanned twice at two different points in time. As always, move the job to the centre of the carousel and start the app. This time the reference surface will be created using data from a point cloud. The data was created using a different scanner, that is, not a multi-station, and the data from that scanner is in a PTS file. The point cloud will be triangulated to form the reference surface, and because there could be literally millions of points forming the point cloud, in the settings of the app it is possible to define the settings on how the point cloud will later be triangulated. Using the appropriate settings will reduce the time needed to triangulate the surface. We press OK and OK again to import the data from the point cloud, and over 650,000 points are imported, but not yet triangulated. This is done later. The second time the dam wall was scanned was with a multi-station, and these scans are stored in this job, so we choose existing scans. In this case, the wall was measured with 2 scans and we select both scans. The colour scale is correct, we confirm the overview information and the results are computed. This time, the first step is to triangulate the reference surface from the point cloud based on the settings we made earlier. This results in almost 20,000 triangles being created from the PTS data. Then the difference between the multi-station scans and the newly triangulated reference surface are computed, and then finally the results are drawn. Once completed, we can clearly see the differences between the 2 scans and, as always, move the results around in the 3D viewer. Let's look at 2 more settings which are useful in this use case. The first setting allows the boundary of the triangulated surface to be displayed. The results are redrawn, and for this use case it is particularly interesting since now we can see any holes in the triangulated surface. If necessary, we could change the triangulation settings and recompute the reference surface. The second setting allows the mesh triangulation to be viewed. Again, the results are redrawn, and now we can see the full complexity of this dam wall in the 3D viewer. And remember, all of this is possible in the field with no post-processing needed in the office. In summary, the Inspect Surface app is a really powerful app, allowing a wide range of objects such as measured points or multi-station scan data to be compared to a reference surface, such as a predefined plane or cylinder, scan data or imported data. As mentioned at the start of the video, this app can save an enormous amount of time and money by allowing the surveyor to make decisions in the field. Previously, such decisions could only have been made after returning to the office and post-processing the measured data. And thanks for watching.